Zaman, Director of Southern Plains Transportation Center. On behalf of SPTC, I would like to welcome all of you, to this wonderful workshop. This is the second half of the workshop that is given by Dr. Andrew Braham from University of Arkansas. This is a very, very important topic that he's going to talk about. As we all know, pavement preservation, maintenance, timely maintenance is really, really important. I'm sorry that my camera is not working, but so please forgive me. But at least I think you can hear me well, Andrew, right? Again, I think this is the second half and a very important topic. So I have had the opportunity to know Dr. Braham for quite some time. So he graduated, from the University of Wisconsin with his BS and MS degree, and then he got his PhD from University of Illinois. He also worked in the private sector in the Coke Materials company for a little bit, and interestingly that he worked in China. He was in China for a while as part of that job. He's currently a professor in the Department of Civil Engineering at the University of Arkansas. And his teaching and research focus on flexible pavement materials, pavement maintenance and rehabilitation, and sustainability. Andrew has published in a couple of books. So he has a textbook on fundamentals of sustainability in civil engineering. These days, we hear a lot about sustainability. So, Andrew, thank you for offering this information to all of us about sustainability. And also, he had a book in the leadership area called or titled Values-Driven Authentic Leadership, Essentials Lessons from the Leadership WWEB podcast series. So one thing, just, those of you who would like to actually get PDH, you should get it as you register. I think those are, we note that, and we'll follow up with your PDH. If you have any questions, please put your questions on the chat box. I don't know, Andrew, how you'd like to. Is it okay if somebody has kind of an important question while you are presenting? Could
yes, sir. There's no problem with that.
I think that would probably be all right because of the nature of this event. It's a workshop, and we want to make it kind of more of an engaging discussions. So that would be great. And one more thing I just want to mention, that SPTC is doing a lot of these kind of activities. We have webinars, you have sometimes we're able to do short courses and workshop. So if you want to actually see a future workshop in an area, just simply, please let us know, and we'll try our best, to offer that workshop and short course, whatever that we could do to make sure that we help you. I think it's not only we help you, you help us too. It's a two-way street. Help is always a two-way street. So that way, then I think we keep our stakeholders informed, and in the process, we get informed also. Working with nothing is more important than working closely with the stakeholders. So with that, I would like to actually maybe Katie, if you let Dr. Braham share his screen with the group. And once again, thank you, Andrew, very much. We know that you're very busy, but you still, took time to actually offer this short course. We appreciate it very much.
Thank you, Dr. Zaman, for the very nice introduction. And I appreciate the opportunities to continue our discussion about asphalt emulsions and flexible pavement preservation. As Dr. Zaman mentioned, this is part 2 of the workshop. Last week was part 1. And last week, we talked about what is pavement preservation, flexible pavement maintenance treatments, asphalt emulsions, and then specifically asphalt emulsions in maintenance treatments. So this webinar is actually posted on SPTC's YouTube channel. So if you weren't able to make it, you can go back and watch it at your leisure. Now, this week, we're going to pivot a little more toward some of the details behind asphalt emulsions specifically, including quality control and testing of asphalt emulsions, and then specification best practices for asphalt emulsion maintenance treatments, and then finally inspecting construction of asphalt emulsion treatments. I often say that we can have the best materials in the world, we can have the best design in the world, but if we don't construct it correctly, if we don't make sure that we have high quality materials, if we don't follow best practices, and if we don't inspect the construction correctly, all of the work that we did up to that point is essentially irrelevant, and you will not get the full benefit of what you are trying to do on the roadway. So today we're going to go over those three areas. So let's continue with asphalt emulsions in flexible pavement preservation. Now, just a little bit of a recap. I wanted to make sure everyone's on the same page of Asphalt Emulsions 101, and specifically the nomenclature or how asphalt emulsions are named, because we're going to go over a lot of examples and a lot of details where this nomenclature is important today. So for setting speed, there are 4 different setting speeds. We have the rapid set, a quick set, a medium set, and a slow set, designated by R, Q, M, and S. There are 3 different particle charges. The first is a negative particle charge. This is an anionic emulsion, and this is represented by no letter, so it's just a blank space. There's nothing there. A positive asphalt emulsion is a cationic asphalt emulsion that's represented by a C. And then there's also neutral asphalt emulsions, which are non-ionic, and those have a pH of around 7. Another very important letter is a capital P, which is polymer. Now, I went over this in a little more detail last week, and Olivia actually posted the recording of part 1 of the workshop in the chat box. So I encourage you to take a look at that. Preferably not while I'm talking now, but if you want to get a quick recap, you could put that on like double speed and try and catch up. But the link is there for you to watch at your leisure. Now, what I wanted to do and why I kind of went over these definitions again is I did want, oh, I'm sorry, my screenshots stopped sharing for some reason. There we go. So the reason that I wanted to go over these definitions really quickly is because I do want to spend some time talking about standards, specifically the 3 different types of standards that revolve around asphalt emulsions, and that includes AASHTO M316, which covers polymer modified asphalt emulsions, and there's 11 different grades of asphalt emulsions within that specification. And Olivia, I apologize, my sharing ability is going on and off quite frequently. Am I doing something wrong on my end?
Katie, could you see what is going on?
I'll see what I can do.
Okay.
Thank you.
Thank you. So if we take a look at AASHTO M316, that is polymer modified asphalt emulsions, and there are 11 grades of asphalt emulsion that are covered under AASHTO M316. If you take a look at AASHTO M208, those are all the cationic asphalt emulsions, and there are 12 different grades covered under AASHTO M208. And you may wonder why I'm going in reverse order. We started at AASHTO M316, we went to M208, and the last one I wanted to highlight was AASHTO M140, which is simply emulsified asphalts. Now, some people make the mistake of assuming that means anionic asphalt emulsions, but in fact, pretty much any type of asphalt emulsion in theory could fall under AASHTO M140. It's that broad of a standard, and so it's simply called emulsified asphalt. Now, they do cover 15 different grades within AASHTO M140, but chances are if you're getting an asphalt emulsion from a supplier, it will fall under one of these 3 different standards. Now, just so you can kind of know what you're getting into, we're going to take a quick look at M208. And if you look at AASHTO M208, a big part of both 208, 316, and 140 are these massive tables. And in these massive tables, along the left-hand column of these tables, you have the different tests that you can run on asphalt emulsions. So you have a couple different viscosity tests. You have both Sabalt-Furel and rotational paddle viscosity. You have a storage stability test, a particle charge test, a sieve test, and for AASHTO M208, a cement mixing test. And then we have what's called distillation. And distillation is where you take your asphalt emulsion, and historically you take that asphalt emulsion and you get an asphalt emulsion residue out of it.
Sorry, Andrew. Katie, could you mute other people because I can hear a background noise. Thank you.
And so this top half of tests are tests on the emulsified asphalt, but then you need to get what's called asphalt emulsion residue. And the traditional method of obtaining that asphalt emulsion residue is through the distillation test. And you get your residue in a percent, and then you also get something called oil distillation, which are lighter fractions of your asphalt binder that come off the top. Then similar to how we can run tests on emulsified asphalt, we can also run tests on the asphalt emulsion residue. And in M208, you can run the penetration, the ductility, and the ash content. So in all three of these standards, AASHTO M140, AASHTO M208, and AASHTO M316, along the left-hand column of these big tables are all the different tests that you run. Then running up along the heading of each of these tables are different grades of asphalt emulsion. And what I did is I just pulled 3 grades out of M208 for an example purpose here. I did a CQS-1H, which is a cationic, quick-set, low viscosity, hard penetration grade by asphalt emulsion. A CQS-1, which is a cationic quick-set, low viscosity with normal asphalt binder, and then a CMS-2H, which is a cationic medium set, high viscosity, hard pen binder. And so these are just kind of for demonstration purposes. But remember, there's 12 total grades in the cationic asphalt emulsion specification. And so if you look at the different viscosity tests that can be run, the -1s, those are the low viscosity. You can run the Sabalt-Furel at 25 or the paddle viscometer at 25. But then the high viscosity, the -2, you're on the Sabalt-Furel at 50 degrees Fahrenheit or the rotational paddle at 50 degrees Fahrenheit. And you can see the ranges of acceptable values are within the table. So in order to be categorized as a -1 asphalt emulsion, the Sabalt-Furel viscosity has to be between 20 and 100 seconds. If you're running the paddle viscometer, it is between 40 and 200 millipascal seconds. So that's the low viscosity, the -1, but if you look on the far right-hand side, that's the -2, and the Sabalt-Furel is between 50 and 450. So the nice thing is you don't even have to memorize that -1 is low viscosity, -2 is high viscosity. You just got to look at the table and you can see the requirements, the specifications for a -1 are lower than the -2. So that's for the viscosity. Then you also have various additional tests. You have the particle charge test. If it's a cationic emulsion, you want it to be positive, therefore it has to pass as positive with the particle charge test. You have the sieve test. So in short, asphalt emulsion is asphalt binder droplets suspended in water, and they are suspended with the aid of emulsifiers. And generally, they're very, very small droplets. We're talking about like less than 20 microns. Well, sieve test is basically taking care of any sort of oversized particles. So are there oversized particles associated with your emulsion? Then you've got some distillation. That CMS-2H has a 12% maximum oil distillation, but you can see the residues vary between these different emulsions. The CQSs both have a 62% residue. That means it's 62% asphalt binder, and then that would mean 38% liquids that evaporate off during the distillation test. And then the CMS is a 65% residue. And then getting down on the test on the residue, we've got our standard friend, the penetration test. And you can see that, again, that CQS-1, that does not have any letter after the 1, but the CMS-2H has the H, and you can see that penetration result is what causes the differentiation between having an H and not having an H. Not having that H means the penetration's between 90 and 250. That means it's a little softer. That needle goes down into the asphalt binder a little more, the asphalt emulsion residue. And then the 2H, that's a hard pen asphalt binder, that's between 40 and 90. So this is just, again, an example. And as I mentioned, there are 12 total cationic grades. There's 11 polymer modified. There is 15 emulsified asphalts. So there's a whole bunch of these different ones, but this is how you actually take a sample of asphalt emulsion and then make sure it's passing and has the properties that you are interested in it having. Now, I went over this table relatively quickly. If you have access to AASHTO standards, I recommend that you take a look at these tables. They're very interesting to look at. There's a lot of nice details behind there. But I did want to go over some of the tests. And some of the tests are shown in AASHTO T59. So when we're looking at grading asphalt emulsions, we have M140, M208, and M316. But then when we're looking at the actual test that can be run, we're going to pivot to AASHTO T59. And so if we look at AASHTO T59, these are emulsified asphalt tests. And we're going to start with looking at the tests that are run on the asphalt emulsion. And they are broken down into various different categories. For example, they're broken down into the composition of the asphalt emulsion. And you have water content, you have the residue and oil distillate, which is shown on the right. You have the residue by evaporation, and you have the particle charge. So in AASHTO T59, these are all considered composition properties of asphalt emulsion. Now, another way to look at it is through consistency. So what are some tests that we can run to measure the consistency of asphalt emulsion? Well, we're going to look at two different viscosity tests, the Seybold and the paddle viscometer. Now, I apologize in advance. I'm a civil engineer. I'm not an artist. All my artwork is done in Excel. So I'm going to try and demonstrate the Seybold test, and you guys can judge as to whether or not you think you get the point across. But the whole point of the Seybold test is you have some sort of container in a bath at a certain temperature that has a very specific hole at the bottom, and it's a Seybold orifice. That's how the test gets its name. You take a cork out, and then the emulsion starts pouring into this little cup. So you take the cork out, you start your watch, asphalt emulsion falls down. You want to make sure it hits the side of that cup so it doesn't get really turbulent. As it falls down, it starts filling the cup. And what you do is you measure the time from when you pull that cork out into when the asphalt emulsion reaches that dotted line. So how long does it take to fill that cup? And if you remember from the previous slide, the Seybold viscosity is measured in seconds. So it's a time. Now, the Seybold viscosity is a relatively old test. We don't run a Brookfield rotational viscometer because, in theory, if you run the Brookfield rotational viscometer, it needs to be a homogeneous material. And asphalt emulsion, by definition, is not homogeneous. So we can also run the paddle viscometer, which is essentially where you have a cup, you place a paddle in, and then you start rotating the paddle, and you measure the resistance. So these are the first sets of tests on asphalt emulsion in T59. That includes composition and consistency. We can continue going through T59, and the next category is stability. So if you remember from the previous presentation, asphalt emulsion is asphalt binder droplets suspended in water with the help of emulsifiers, but over time, asphalt emulsion flocculates, which means the particles start to come together, but you can separate them. It starts to coalesce, which means those droplets start sticking together and you can't separate them. And then the water eventually leaves the system, and that's a full break. Well, we're very interested in making sure that we can store the asphalt emulsions in a tank for a period of time before shipping them to the job site, so they need to be stable. And so one test is a demulsibility test, which is essentially where you drop some chemical into your emulsion and you stir it and you see how long does it take for the asphalt emulsion to start coalescing? How long does it take for those binder droplets to start joining together and your asphalt emulsion breaks? So the demulsibility is a relatively newer test, but the old school way of doing this test is just to simply dump some cement in there. So you have a little bit of reactivity from the surface chemistry of the cement. You also have a very high surface area of the cement particles. So this is another way you can quantify the breaking characteristics of your asphalt emulsion, and you can measure how stable your asphalt emulsion is. Now, I had mentioned the sieve test. You literally take your asphalt emulsion and you pour it through a screen. And you rinse that screen and you measure how many particles have been retained on that screen. And these are very large particles. If you recall, it was 0.1% is the maximum for the sieve test. And that's because these are very oversized particles. And these are not good for asphalt emulsions. They cause problems with pumping. They cause problems with spraying for chip seals or fog seals or scrub seals. And then they also cause problems for good mixing when you're doing slurry seals, microsurfacing, cold in place recycling, full depth reclamation, hot in place recycling, any sort of mixture test. So you want to have a low amount of sieve. Then we also have the storage stabilities test. So for storage stability, you essentially just put your asphalt emulsion in a big old beaker or a big old graduated cylinder, and you just let it sit. And over a 7-day period, you measure how much of the asphalt binder droplets have sunk to the bottom, and then how much of the water has kind of risen to the top. So the heavier particles drop due to gravity, and the lighter particles then are more suspended in the top. And so you can actually see a gradient of colors. And then finally, we have coating tests. So there's various tests that measure how well the asphalt binder or asphalt emulsion coats particles, how much it covers the particles. You can do that both in the lab and the field. And then there's also some density tests. So I went over some grades of asphalt emulsion, and we're starting to talk about some of the tests on asphalt emulsions. But before I go on to the tests on the asphalt emulsion residue, as Dr. Zaman mentioned, if you have any questions, please feel free to put the question in the chat box or raise your hand, and I'd be happy to take questions as I'm going along.
So, Andrew, I have a question that in terms of these tests, I think, first of all, I think this is a very important topic because not too many people work with the asphalt emulsion as if you compare to that other side, the regular asphalt binder, right? So in terms of repeatability of these tests, right? So if you take emulsion and as you said that these particles, coalesce with time, and that can be a stability problem. So based on your understanding, what are the repeatability of this test and reliability for that matter?
It's my opinion that these tests have a very high level of repeatability. And that's because the majority of these tests are more than 50 years old. So they have a very long history of being used. And it's my opinion that when you are making an asphalt emulsion on a regular basis, you begin to understand the chemical formulations very well, the temperatures very well. And so when you continue to make these asphalt emulsions over time, you are able to make a very consistent product. Now, from a research standpoint, I think this becomes a little more difficult because then you can start experimenting with different things. You can start pulling the different levers of temperatures, of asphalt binder quantity, of emulsifier type. And once you start pulling those levers, then I do think you want to be very careful with these tests, and you want to make sure that you're very comfortable running them because you may start to get asphalt emulsions that are not as common as what, say, a plant makes. But that's an excellent question.
Yeah, thank you. But there is, I cannot see all of the participants. We have a large number of participants. So could you someone has raised hand. Could you kindly unmute and ask your question?
Yeah, thank you, Professor Andrew. Very nice presentation. I have a short query. Slide number 4, you have shown some emulsion, different type of emulsions.
Mhm.
Yes. So over here we can see that the residue bitumen is 2H, right?
Mhm.
Uh, I want to know, like, if the base binder is same in CQS1H and CMS2H, what's making the difference? Which component is over there, which is making the
Mhm.
viscosity different by
Mhm.
which is 20, 100, and 40, 50, and 450? Thank you.
Yes, Ankit, that is an excellent question. And this is something that I have a very high interest in. The nice thing is this table that we're seeing here is blind to any asphalt binder type. It's blind to any emulsifier you use. At the end of the day, it doesn't matter what your base materials are. What matters is the final product and how that performs. So for example, here in the state of Arkansas, we're in the southern United States, and we use PG 64 minus 22 quite a bit. You go up to Wisconsin, which is where I'm originally from, and I love Wisconsin. They use a lot of PG 58 minus 28. So that's a much softer binder. So the idea is if you're in Wisconsin or if you're in Arkansas, it doesn't matter what the base binder is. What your job is when you're making emulsions is if you want to make a CQS-1, it's your job to put the proper ingredients together in order to hit all those numbers. If you want to make a CMS2H, you might need to tweak this or that. There are some things that you can change with base material properties, with the formulations that you're using, those type of things, then in order to alter how you actually get there. And I think I like to equate it, Dr. Zaman was right on. Not as many people work with asphalt emulsion as traditional asphalt materials like hot mix asphalt and warm mix asphalt. But it's very similar to warm mix asphalt. There are various ways to reduce the mixing and compacting temperature. You can add a chemical, you can use a foaming device, you can use a wax product like a Sasabit or something. So there's many different ways to get to the end. It doesn't really matter how you get there, just as long as you're able to get there where you need to go. There's many different ways you can do it. So this is blind to really anything. It's not telling you how to make your emulsion. It's telling you how to run the test in order to classify your emulsion. But that's a fantastic question.
Thank you very much. I got your point. Thank you very much.
Thank you. Excellent.
Please proceed.
So there is a question about obtaining the specifications. And Rama, I do apologize. In fact, I'm not even sure I should have posted what's on this slide because this is an AASHTO standard. AASHTO has copyrighted their standards. We're not able to distribute them. But the good news is that there are some free resources out there that are available that can be downloaded anywhere. And I'm going to cover some of those a little later in this presentation. But as far as like AASHTO M208 goes, it's not possible to distribute that because it's a copyright standard. But thank you for that question. So we spent a little bit of time on AASHTO T59 talking about the asphalt emulsion tests. Now, AASHTO T59 also has some tests for the residue, so the asphalt emulsion residue. So we have the specific gravity, we have the ash content, which is how much non-combustible material is in your asphalt emulsion residue. We have solubility as a test. Then we have the classic penetration test, and I always like talking about this test for two reasons. One, it's probably the most historic asphalt binder test that we have in our toolbox. But two, this is literally a sewing needle that is used in the penetration test. The gentleman who created it, he was looking for something to poke into an asphalt binder sample. He went to his wife's sewing kit and took a sewing needle out, put a 100-gram sample on it, and measured how long it takes for that sewing needle to sink into an asphalt binder sample. how far it sinks in 5 seconds with that 100-gram weight on it. So it's a classic test. Now we also have ductility. Ductility is where you take your sample and you start pulling it apart and you pull it until it breaks, or the limit of the test. That is the ductility, basically how stretchy the asphalt emulsion residue is. And then the float test. The float test has to do with high float asphalt emulsions, and it's a very special category of asphalt emulsions. But again, doesn't matter how you make it, but if you run the float test on the asphalt emulsion and it passes, then you have a high float asphalt emulsion. Now, these are all the AASHTO T59. And when we're talking about specifications, a lot of state specifications, a lot of local specifications, they do have a lot of the AASHTO T59 tests in their specification. But I wanted to give a call out to some more tests that are out there and available. For example, the residue recovery. So when you're running the distillation test, that's the classic test in order to get asphalt emulsion residue. That's at about 500 degrees Fahrenheit, which is an extremely high temperature not seen in the field and is not representative of how asphalt emulsion loses its water, how it breaks and loses its water in the field. So we have AASHTO T59, which are different alternative residue recovery methods that have slightly lower temperatures, so you don't heat your asphalt binder or asphalt emulsion residue up as high as is necessary for the distillation test. So we have section A and section B, and you can see lower temperatures, longer times in order to get your residue. So there's pros and cons to that. Then in R78, we again have procedure A and B, and these are even lower temperatures. So the default distillation temperature, that AASHTO T59 section A, is 500 degrees Fahrenheit. It only takes 15 minutes, which is fantastic. But then these more ambient temperature, more representative temperatures that you see in the field, AASHTO R78, procedure A and B, these take much longer, 24 hours at 77 degrees Fahrenheit plus 24 hours at 140 degrees Fahrenheit, or just 6 hours at 140 degrees Fahrenheit, and that's at a thinner layer. Now, if you're interested in this residue recovery, Mike Anderson at the Asphalt Institute has been doing a fantastic job in NCHRP 9-63. He's building on work done by Dr. Amy Epps Martin at Texas A&M and Dr. Richard Kim at NC State, who've done a lot of work in this area. But I encourage you to take a look at NCHRP 9-63, and hopefully we'll be getting some of those final reports in the upcoming months. We also have elastic recovery. So if you remember, ductility is where you pull your sample and it either breaks or it pulls to the limit. Elastic recovery is where you pull to a certain limit and then you cut it and you see how much the sample rebounds. And this is very, very important when we're talking about polymer, because polymer has that rebounding action. And there are other additives that can simulate polymer in a lot of ways, but they will not be able to pass the elastic recovery test. So AASHTO M316 explicitly states elastic recovery to ensure that you're putting polymer in. And this can be an SBS modified asphalt binder base, or it can be a latex modified asphalt emulsion. And then also the softening point is included in this test. So these are some additional tests that are in the different AASHTO M140, M208, and M316. And I think there'll be a lot of information about this residue recovery coming up in the upcoming year for sure, because I think that's a point of very large interest. So these are the tests, and the title of this section was Quality Control and Testing. So we went over the tests. Now, how do we start trying to wrap our heads around quality control? And this is something that I've actually gotten very interested in the past 5 to 7 years. I think that the concept of quality is not quite as appreciated as much as it could be. So we're going to look at 2 perspectives for quality. We're going to start with the lab perspective of quality and then a field perspective of quality. So the lab perspective of quality is everything AASHTO R18. And AASHTO R18 essentially helps you build a quality management system. And they start you right at step 1. So they have 8 management areas, and this includes making sure you're tracking documents, mapping out your organization, establishing the proper staff. You really should have a quality manager, someone who is in charge of the quality perspective. It goes over what sort of technicians you need, how do you train those technicians, and then how do you evaluate it? Because when you think about it, you got different people running these tests, and Dr. Zaman asked how repeatable they are. Well, if the technicians have proper training and they're properly evaluated, in theory, anyone running that test should be able to get a high quality, repeatable result. But like any test, if you're not running it correctly, you're going to get some poor results. It's important to have internal audits. This is a way to kind of self-reflect and make sure you're doing everything correctly. And I really like this. It's not often that you get to pick on management, but there's a lot that needs to be done in the weeds on the tests and those level. But also you need to make sure that management's 100% involved with this as well, because it does take extra resources. It takes a little time, it takes a little money, but if you're pushing out a consistent product, it becomes well worth it. You need to make sure that there are mechanisms in place for any sort of corrective actions. So let's say you're running a test and you get like 65% residue for a couple months, and then literally overnight, it shifts down to 64.5. And you start getting 64.5 for a while. Well, 2 things could have happened. 1, you could be making the asphalt emulsion differently, or 2, something could have changed in the lab while you're testing. And so you got to make sure that you recognize if things are starting to go in a direction that you're not expecting, you have some sort of corrective actions available. And then finally, records are very important. We're only as smart as the data that we have. And so we need to make sure we maintain that data and have that data available in order to benchmark what we're doing today with what we've done in the past and to be able to predict what we're doing in the future. Now, these are the management areas. There's 8 management areas, just kind of global ideas on how to organize your quality perspectives. There's also 9 technical requirements. So you want to make sure you have a good equipment list. Again, you need to have the right equipment and the right peripheral resources in order to run these tests. You want to make sure you have both general equipment procedures and individual equipment procedures. So what are you doing with all of your equipment? That's like cleaning practices, starting up, shutting down, but then also every individual piece of equipment has their own certain procedures. You want to make sure you are calibrating and checking your equipment on a regular basis. That's the equipment intervals. And also that you are recording all of this information so you can track it and make sure things are being done correctly. And then sample management. You can run the best test in the world, but if you're not taking care of that sample, you take it out of a tank in the asphalt emulsion plant, you bring it to the lab. You want to make sure it's stored at the right temperature, and you want to make sure it's tested in a timely manner, because asphalt emulsion does change over time. And then finally, the records and reports are important. If you're running all these tests, you want to make sure capturing the data and recording it. Sometimes these pieces of equipment can get a little expensive. Sometimes it's not worth having every single lab having these pieces of equipment, so you may need to do some subcontracting. And then finally, you want to make sure that you're assuring the quality of the results. So this is a very broad overview, and I think some people kind of start zoning out when you start to talk about quality, talking about management areas, talking about technical requirements, yada, yada, yada. But when you actually start thinking about these things, it really brings to the forefront the importance of being diligent when you're tracking testing, when you're tracking results. Because again, the data is only as good as how we generate it. And we want to make sure that when we're running these tests, we're running them correctly, we're recording the data correctly, and we're tracking everything correctly. So that's all in the lab. And now we can kind of pivot over to the field. And when we're thinking about field quality, we're just going to look at an example of an asphalt emulsion. And so I'm going to have 3 columns here. The first column is the process control test. So what kind of tests can you actually run in order to quantify the quality of emulsion in the field? We're going to talk about specific test measures that can capture that process. And then we're going to talk about the frequency. So for example, viscosity, you can use either AASHTO T59 or T382. T382 is the paddle viscometer. And according to this example that I'm showing here, you want to run viscosity once per every 48,000 gallons of emulsion placed. And if you're looking at, a half gallon per square yard or something like that, that's about 90,000, it's about 100,000 square yards. Every 100,000 square yards of coverage, if this is a chip seal, you would run a viscosity test. And that allows you to test material as you're placing it on a regular basis as you go down the road. You want to make sure that your emulsion's at the right temperature. And so every time a new tanker comes with a new batch of asphalt emulsion, you want to check that temperature. You want to check particle charge and demulsibility. And so for particle charge, it's recommended to check it once prior to loading the emulsion distributor. And then for demulsibility, it's the same as viscosity, once per 48,000 gallons. All three of these, sieve, storage, stability, and residue, these are also once every 48,000 gallons. And then the application rate. So this is what's actually being placed down in the field. You want to make sure that you're properly capturing how much material is actually being placed on the roadway once at startup each production day, and then every 48,000 gallons. So these are from one of the quality assurance documents that the AASHTO Emulsion Task Force has developed. And this is just one example of a group of experts who came together and said, these are the important tests that we need to run to make sure the material we're placing in the field is representative, and this is how often we think they should be run. So these are interesting numbers because they actually put some data behind how can you track to make sure your emulsion is doing what it needs to do in the field. All right, so next we're going to pivot to some treatments. So again, if there's any questions, I encourage you to either raise your electronic hand or toss a question in the chat box. All right, no problem. I can keep going on for sure. Now, if you joined us last week, this is kind of my mindset. I'm a little unique in many ways, but when I think about maintenance treatments for flexible pavements, I think of just taking care of the surface. When I think about rehabilitation treatments, I think about taking care of the structure. So this is kind of how I delineate maintenance versus rehabilitation for flexible pavements in my mind. So some of the maintenance treatments, we got fog seal, both standard fog seals and rejuvenated fog seals. We have chip seals, sand seals, and scrub seals. So these all involve placing some sort of aggregate on top of sprayed asphalt emulsion. We have slurry surfacing, and slurry surfacing is a combination of slurry seal and microsurfacing. And then we have ultra thin bonded wearing courses, and we have combination treatments. Now, there are several AASHTO resources. In addition, I don't have this written down, but I want to give a shout out to roadresource.org. If you have not been to roadresource.org, I encourage you to go there. They have a very good overview of all of these treatments on roadresource.org. And you can go there, it's free of charge, click on whatever you want and check it out. But AASHTO has also done a tremendous job of developing resources for these treatments. And the AASHTO resources that have been developed include material standards, design practice standards, construction guides, and quality guides. And these have been developed for chip seals, microsurfacing, slurry seals and fog seals, sand seals and scrub seals, and ultra-thin bonded overlays. So if you have access to AASHTO standards, you can see these are the actual AASHTO material standards. They go from M340 to M346. And the design practice standards, they go from R102 to R108 for all of these treatments. And there is an incredible amount of information in both of these material standards and the design practice standards. And Rama asked if there are free online resources, and good news, there are free online resources for these, which we'll get to in a second. The construction guides are also being developed. Now, the construction guides themselves are not available free for download, but you can download the research reports that developed the construction guides. And kind of in theory, all the information that's in the construction guides and the research report, there's a lot more in there, but the research report has all the information. So if you Google NCHRP 14-34, excuse me, NCHRP 14-37, NCHRP 14-44, or NCHRP 14-48. I think you can download the 37 and the 44 final reports, and the 48 final report should be coming out shortly. That project just finished up. And then you can see there are also quality guides for all but the fog seals. Now, as you're Googling, you can also Google Emulsion Task Force. And if you go to the Emulsion Task Force webpage, and if you click on specifications, there are draft documents of these available online free of charge. And I'm actually going to go over some of these draft documents, so I apologize in advance because they have watermarks on them, but you can download these, you can still read them. It's a little clunky, and there are a couple small changes between the draft documents and these final approved standards, but they're all here available for you to take a look at. So let's take a look at chip seals. Chip seals is by far the most common treatment, maintenance treatment that's applied to our roadways. So if you look at AASHTO M340, there are 3 different asphalt emulsion standards that need to be followed, whether you're using just a standard emulsified asphalt, that's M140, a cationic asphalt emulsion is M208, and a polymer modified asphalt emulsion, which is M316. We have 4 different gradations, and you can see the gradations are labeled A, B, C, and D. And you can see they have a maximum size of 3/4 inch, 1/2 inch, 3/8 inch, and 2 of them are 3/8 inch. But that D is much smaller than the C. It's a finer gradation. But these are the 4 gradations, and there's 2 things that I would like you to notice on all 4 of these gradations. One is they're very single sized. So for example, if you look at A, almost all of the aggregate is between 3/8 inch and a 1/2 inch. If you look at B, almost all the aggregates between the number 4 and a 3/8 inch, and it kind of steps down as you get higher in those letters. So single size aggregate are very important for chip seals. And also, if you look at the dust, all of the dust is low. Dust is also the P200, and you can see it's between 0 and 1% for all but the D, which is between 0 and 3. So they're very, very clean aggregate gradations. And there's also other various aggregate properties, fractured faces, LA abrasion, flakiness index, these type of things. And you can see here they have different classes, and those classes are based on traffic volume. So I mentioned the chip seals are one of the highest used maintenance treatments for flexible pavements, and there's a lot of them that go down on low volume roads, so less than 500 AADT. But then you can see that chip seals can very successfully be placed on higher traffic roads as well, but the requirements change for fractured faces, LA abrasion, and flakiness index. Now, again, if you go to the Emulsion Task Force webpage, you can download the full working draft of the standard. I just took some screenshots, which is why that watermark is going across at an angle. Now, for the design, that's R102. This is pretty exciting. For the aggregate, you use the board test for the spread rate. Basically, as the aggregate comes out of the chip spreader, how is it falling onto the pavement? What's the distribution of particles? What's the quantity of particles? You can simulate that with the board test. And so you run the board test and you get approximately the amount of aggregate that you should put down. And then Dr. Zaman said I wouldn't get paid for this. I'm getting paid $0, but I wouldn't get paid for this if I didn't show an equation. So here's my equation. And this equation is the emulsified asphalt quantity. So you have your aggregate rate, and then you have your emulsion rate. And you can see the emulsion rate is capital A, and the emulsion rate is a function of the embedment rate. So how much of those chips going down into the emulsion, the traffic, the existing surface, all of these different things. And you can see them all listed under that list of variables. And so once you know what your board test spread rate is, that is capital Q, you then find all those other values and you can get an approximate asphalt emulsion spray rate. Now, I do want to point out that there are conversions and adjustments that you can make if you have a very dry pavement, so high oxidation, high raveling, or a very flushed pavement with a lot of asphalt binder at the surface. You can adjust the shot rate a little up or down for chip seals. But this is kind of how you get your general shot rate based on the general aggregate, based on the general embedment that you're looking for, based on the general traffic in your general existing surface. So that was the materials and the design. This is the construction guide overview. So there's 7 sections in all of these construction guides. You have a description, and here you have a very nice description of the AASHTO construction guide overview. Basically, they're saying this is for chip seals, and this is what a chip seal is. Application of emulsified asphalt, followed immediately by a single layer of aggregate chips to a prepared surface. So that's the description, and all of the construction guides have that at the beginning. Then you have some reference documents. So what inside the construction guide actually references an external document. All of those have to be listed, basically the bibliography. You got some terms. If people aren't familiar with some terminology, they do define some terms. That's section 3. And then the materials are listed there. So for chip seals, it references the 3 emulsion standards, M140, M208, M316. And then also M340 and R102, that's the chip seal materials and the chip seal design. So this is all referencing these other resources that are already available. I'm going to come back to construction. This is the construction guide overview. So that's the most important portion. Then we have measurement and payment. So basically this is how do you measure the emulsion and the aggregate, and then how do you pay for it? And usually payments are unit price or completed in a chip seal. And a very key section here is construction. So this is where the meat of the construction guide occurs. Now we have we got a question here about how stress absorbing membrane interlayers are used in each of the surface treatments. Oh, that's a great question. First of all, thank you for asking the question. So a SAMI, my definition of a SAMI is something that's put in between 2 flexible pavement layers. And in short, if you have a distress on that bottom layer, you don't want that distress to go up through into the top layer that you put on. So a SAMI is an interlayer, something you can put in between. I usually tend to think that SAMIs are only used when you have 2 asphalt mixtures, one on top of another. Now, one of the SAMI materials can be a chip seal, but I'm not very familiar with SAMI being applied between an existing layer and a maintenance treatment. That's just my experience. But thank you for the question. I do appreciate that. So that's a little SAMI deviation, but I do want to dig a little into construction. These are the construction guides. So by far the most, the meat of this document is in section 5, the construction section. So in section 5, we talk a lot about equipment. So when you think about when you go out on a chip seal job, first of all, if you've never been on a chip seal job, I highly encourage you to go out on one. Call your DOT. They all have chip seal crews, or they're placing chip seals somewhere, I guarantee you. And I bet they would be very happy to give you a tour of a chip seal job. And when you get out there, you see an asphalt distributor. That's what sprays the asphalt emulsion. You see an aggregate spreader. That's what places the aggregate in that nice even layer as you're going down the road. You have a pneumatic tire roller. So you do not compact a chip seal. You seat the aggregates for a chip seal. And you do that using a pneumatic tire roller. Then you have brooms to kick off excess rock. And then obviously you have trucks, bringing new emulsion in, trucks bringing rocks in. So you got a bunch of truck traffic too. So all this type of traffic is covered under the equipment section of construction. Now, I talked quite a bit about quality, right? I talked about quality in the lab and quality in the field. A huge part of quality is also equipment calibration. Folks, this is something that cannot be skipped either in the lab or in the field. If you have a piece of equipment, it will give you a number or it will do something pretty much all the time. If it's not calibrated, though, it will not give you a number that's correct, or it will not perform as you're expecting it to. So, for example, for the distributor, this is what sprays the asphalt emulsion out. You want to make sure that the nozzle angle is correct because they're little nozzles that are spraying the asphalt emulsion out, and they're oriented in such a way where it's 15 to 30 degrees off center. You want to make sure your spray bar is at the right height, and you want to make sure your transverse, so side to side, and your longitudinal up and down the roadway, you want to make sure you have a consistent shot rate. You don't want to have waves going from left to right. You don't want to have it really heavy, really light, really heavy as you're going down the road. You want nice and consistent, left to right, forward and backwards. And that's a big part of equipment calibration. For the spreader, it's the same thing. You don't want to dump a pile of rock here and have none over there. You want to have it nice and even as you go down the roadway, both side to side, transverse, and longitudinally, forward and backwards. Pre-construction meetings are very important. You want to make sure everyone on the job site is on the same page. You want to make sure the owner, the material suppliers, the contractors, they all know what's going on and they're all on the same page. That all happens during the pre-construction meeting. Also, any safety considerations are discussed in the pre-construction meeting. And then, folks, I know I say a lot of things are important. I probably said that like 15 times already in this presentation. I cannot emphasize enough the importance of properly preparing a road for a surface treatment. So if you don't believe me, the next time you need to put a Band-Aid on, like if you get a cut on your arm, you want to put a Band-Aid on, go put some dirt on around the cut and then try and stick that Band-Aid on. The Band-Aid will adhere to the dirt and it'll come right off. It will not stick to your arm. It is exactly the same thing with any sort of surface treatment. If you have a dirty road surface, your asphalt emulsion will stick to the dirt and it'll come right off. And that's just horrible. You don't want that. So you want to clean the pavement. You want to protect all the accessories. So any manhole covers, curbs, whatever you need to do, crosswalks. And then also you want to remove stripes because those thermoplastic stripes, sometimes you don't get good adhesion between emulsion and those type of materials. So you just want to micromill those type of things off. And then finally, during the application itself, some people think that in the construction guide, during construction, you only really care about when you're applying the material. That's just one small part of the construction section of the construction guide. All this other stuff is also important. For the application, you need to have proper weather conditions. Asphalt emulsions, 33% water. And what happens below 32 degrees Fahrenheit with water? It freezes. And if your water's freezing in emulsion, you no longer have an emulsion. That's a problem. So applications usually 50 degrees Fahrenheit and rising temperatures. You don't want it raining. You want to place a test strip. You want to make sure that test strip is allowing you to properly place emulsion and aggregate. Use paper joints to get real nice, clean construction joints. The rolling and the sweeping, make sure your aggregate's going on at the right level and you get excess off. Traffic control is very important as you're moving down the road. You might have a moving work zone. And chip seals are notorious for breaking windshields. So you want to make sure that you protect motor vehicles. And then finally, if you're making a chip seal, if you have never placed a fog seal on a chip seal, I encourage you to think about it. That's something called a combination treatment, but that gives a nice black color to your road. It keeps those chips down in the roadway. You don't have a lot of lost chips, and the traveling public will think you paved a brand new road.
And there are a couple of there are a couple of questions in the I just wanted to bring it to your attention.
Thank you, Dr. Zaman. Yeah, I agree. My point is there's a lot of good details in here. So I encourage you to go to the Emulsion Task Force website and you can look at these draft forms of the construction guide specifications. But as Dr. Zaman mentioned, we do have a question. The first one is, can we control the properties of an asphalt emulsion? 100%. So asphalt emulsions are dependent on essentially three things: your base asphalt binder, the emulsifier that you're using, that's the chemical that you're using, and then any sort of water. And usually if you have potable water, you're fine. So you just use city water. But by changing the emulsifier, by changing the quantity of the emulsifier, by changing the asphalt binder grade, you can change almost anything about any asphalt emulsion. So that's a great question. And I encourage you, if you go to some emulsifier companies' websites, I am not promoting any one single emulsifier company, but there's four big ones. There's Nurion, there's Ingevity, there's Arkema, and there's Cow. If you go to their websites, you can download product information sheets about them. So you can say, if you're doing a chip seal, we recommend these emulsifiers. If you're doing a slurry seal, we recommend these emulsifiers. You can kind of match different emulsifiers to different treatments. And some of those websites, they even have the approximate dosage, how much of the emulsifier you can use. And then also, I should mention, if it's a cationic, you can change how much acid you have or the type of acid. If it's an anionic, you can change how much base you have or the type of base. That can also impact it. So I think of it as a bunch of levers. You can push and pull all these different levers, and you can change the asphalt emulsion properties, and you can absolutely make an emulsion that will degrade more quickly if you go in a zone that you shouldn't go in. So that's a great question. Second question is can you have a charge incompatibility between the emulsion and the aggregate? Absolutely, 100%. So I mentioned that anionic emulsions have a negative charge, cationic emulsions have a positive charge. I'm going to make a couple of generalizations here, but in general, upper Midwest has a lot of positively charged aggregate, which means anionic emulsions tend to work better with those aggregates. Most of the rest of the country, and again, these are generalizations, have a lot of negatively charged aggregate. So there's a lot of cationic asphalt emulsions. So you want different charges so that binder sticks to your rock. So if they're opposite charges, they'll come together and they'll stick. If they're similar charges, they might have a little more of a problem sticking to each other. Now, that is a huge generalization, and I'm going to make two caveats to that generalization. One is that if you go back in literature, anionic emulsions were the only emulsion up until about the 1960s, and then cationic emulsions were created. Since that has happened, the vast majority of new asphalt emulsion plants that have been built have been cationic plants. And the reason for that is because you have a lot more flexibility with cationic asphalt emulsions than anionic emulsifiers. You can do a lot more unique things. And I could go off on that topic for a while, but the point is that yes, you can have incompatible emulsions with aggregates, but you can overcome those often with changing your formulations. All right, so there is another question, but I'm going to go on a little further, and maybe when we get a couple more questions in the chat box, I'll take another little break for questions. But please keep them coming. These are great questions. All right, so we talked about the AASHTO chip seal materials, the chip seal design, the construction guide. Now this is the quality assurance guide. So the quality assurance guides, they follow AASHTO R10 for the definitions, and this includes quality control, or QC, agency acceptance, and independent assurance, or IA. So for quality control, this usually revolves around what the contractor can do. So what sort of personnel do you have, the labs and equipment you have, what sort of activities you're performing, do you have a plan for the job, what records and documentations do you have, and then are you complying with specifications? So this all kind of falls under the contractor's wheelhouse. But then the agency or the owner needs to accept this material. So they also have a set of tasks that they need to do. So they need to take care of sampling and testing. They may be in charge of traffic control. They want to make sure that the surface preparation is being done correctly, that the equipment is calibrated, that you're putting down the right application rate, and you're inspecting the material that's going down. So these are all things that have to be done on the owner side. And then The quality control tends to be under the contractor. The agency is the owner. If they disagree with something, then the independent assurance comes in. And this is basically an independent third party that gets triggered if there's an issue between the first two. And this is intended to be an unbiased independent evaluation. And if you want to learn more about it, I encourage you to download FHWA-HIF-12-001. And that is everything that you want to know about independent assurance. So there are a lot more good details in here. And again, you can find draft quality guides on the Emulsion Task Force website. So this is kind of the summary of the documents. I encourage you to try and get a hold of these. If you can't, then I encourage you to go to the Emulsion Task Force website because I only had an hour and a half for this presentation, and there are just a lot more things that you could look into. All right, now before we get into inspection, that is the third part of this presentation. We do have a couple different questions. So the first question is, discuss the factors between a cold mix asphalt and kind of compare that to hot mix asphalt, and specifically around the concept of stability. It is my opinion that you can design and construct a cold mix asphalt pavement layer that meets the same requirements as a hot mix layer in almost any application. But again, it goes back to the proper materials, the proper design, and the proper construction. Now, my one caveat to that is surface courses, especially for either high volume or fast moving traffic. I'm not 100% sold that cold mix asphalt can be used on, for example, like interstate surfaces. I think that the traffic may just be too abrasive for that, but there's a lot of lower volume roads out there for slower moving traffic where I think the cold mix asphalt, if designed correctly, if you use the proper materials and it's constructed correctly, will have very, very similar performance to hot mix asphalt. Got a question about reclamite. Reclamite is a type of clay, thinking off the top of my head, and it can be used a lot in as a type of emulsion. So there are clay emulsions, and I'm actually not going to get into those because those are kind of a completely different set of emulsions. But Robert, if you want to shoot me an email reminding me of that question, I'd be happy to send you some more resources on reclamite. But that's a pretty niche area. It's a great area, but it kind of goes beyond the scope of this. So just shoot me an email and I'd be happy to get you some resources on that. And then the final question is about aggregate charges, and they can change with time, moisture level, and those type of things. And Dr. Zaman answered his own question. It's important to monitor these. If you've got a stockpile that gets rained on, run a moisture content test because that's going to impact how that aggregate behaves with that emulsion. If you have a stockpile that just gets crushed, there are some theories out there that has a higher reactivity than older aggregate. And again, you need to make sure that you're running those periodic tests, whether it's every 48,000 gallons, whether it's every 1 mile or whatnot. If you're very diligent about running these quality tests, you should be able to catch these things ahead of time. Or if you see a very sudden change in what is going down on the pavement, then you kind of go back and ask, well, what just happened that could have done this? Did we just get a fresh load of aggregate? Did we get a new load of emulsion? Those are the type of things that you need to track, which really drives home the point of implementing these quality procedures. Because if you're implementing these quality procedures, you're tracking all of these things, you're documenting them, and you can very quickly see if something's changed from one moment to another. So some great questions here. I really appreciate it. And we've got 21 minutes left, and I'm glad that people are asking questions during the presentation because no one wants to listen to me talk for 75 minutes straight and then rush through 15 questions. But what I'm going to do is I am going to kind of wrap up the rest of my content because it's one more section, and then I'll finish off with questions for as long as people need. So when we talk about inspection, there are two different resources. The first is the FHWA Pavement Preservation Checklist Series. These are all free to download online, free of charge, available to anyone. And then the ISA Design and Inspection Manual. So if you search 2019 Pavement Preservation Checklists, those are all the flexible pavement treatments that they have available online to download for free. The ISA Design and Inspection Manual for slurry seals and microsurfacing is free if you're an ISA member. If you are a government agency, you get free ISA memberships with your .gov email address. So if you work for a government, you can get the Design and Inspection Manual free of charge. And what I'm going to do is I'm just going to go over the FHWA checklist, one of the checklists, and I'm going to keep on chip seals because we've been talking about chip seals in order to go for it. So the FHWA HIF 19029 is the Pavement Preservation Checklist Series for chip seals. And it has various different sections in it. It has its preliminary section, the pre-application inspection, project inspection, opening to traffic, cleanup, and then it has a bonus section. And what I'm going to do is I'm just going to very briefly break down each one of these categories. I don't want to go into too many details because they're all available online. I just want to show you what is available. So for document review, you want to make sure the project's a good candidate. You can have the best materials, the best design, the best construction crew, but if it's the wrong treatment on the wrong road, it's not going to perform like you want it to. And you want to have a materials check. So whether it's emulsion based, whether it's asphalt rubber based, whether it's hot applied, you want to make sure that you're checking all your materials for those quality tests. And then you want to make sure you have compatibility between your binder and your aggregate. You're using approved suppliers and you're using the proper sampling and testing of properties. And you can see there the document review. Those are the different documents that they recommend you establish and review before starting your project. Now for the pre-application inspection, a big part of that is pavement surface preparation. You also want to inspect your equipment. And again, this involves your distributors, your chip spreaders, your haul trucks, your rollers, and your sweepers. Weather is a huge consideration. So if we take a look at the weather section of the checklist, there's all those words over there. I could read through all those and probably about half of you would fall asleep by the time I'm done with it. But you need to put it down in daylight. You want to have proper temperatures. You don't want to have precipitation. You want to beware of high winds, and you need to be cognizant of the humidity level. So when you're thinking about weather, you're thinking about daylight, temperatures, moisture, and wind. Those are the big four things that you want to keep your eye out for. You want to make sure that you have designed for the proper application rate, and then as you move down the roadway, you are staying with that proper application rate. And there are various ways that you can measure the application rate. There's 2 for asphalt and 2 for aggregate. And if you go to the checklist, they go through all of the details of those 4 total methods. And then they have a traffic control section as well. When talking about the project inspection, you want to make sure as you're applying the asphalt, as you're applying the aggregate, they are going down correctly. That includes the trucks operating correctly, the correct rolling applications. Longitudinal joints are a very big deal. There's 2 different methods for longitudinal joints. You can overspray a little bit of emulsion or hot applied on the side, and then when you do the next lane, you cover that up. Or you can take your end nozzle and turn it 90 degrees. So it sprays at a 90-degree angle, and it doesn't spray at that 30-degree angle, which makes material go off to the side. So you kind of turn it to get a line. You've got both longitudinal joints and transverse joints that you have to worry about. So for transverse joints, especially for construction joints, you usually lay down some felt paper and you start spraying on that felt paper. When you lift that felt paper up, you have a real nice clean transverse joint. And then you have to worry about sweeping as well. Now we're opening to traffic. You can use pilot vehicles. If it's a low enough volume road, you can just post signs and have a 25-mile-per-hour speed limit until it's swept. You want to make sure you have temporary pavement markings after the sweeping. Often chip seals are left open overnight. That gets an excess rock off, that gets a nice good seeding of the aggregate, and you don't want to put the pavement markings on too soon, or else aggregate may become dislodged, and then your pavement marking leaves with the aggregate. So you want to have some sort of temporary pavement markings. Once your pavement's fully open, you want to make sure you remove all construction signs. And then one nice thing about asphalt rubber or hot applied chip seals is that once the final sweeping is complete, you can immediately open it to traffic because you don't need to wait for any of the asphalt emulsion water to evaporate. Because it's hot applied, once it's cooled, you can put that traffic back on. Second to last section is the cleanup. You want to make sure you sweep your loose aggregate, and you don't want to reuse that aggregate. So if you look on the side of the road in this picture, there's a little bit of excess aggregate there. You don't want to pick that up and reuse it because it's very dirty, has a lot of deleterious materials in it. That would be a very low quality chip seal or a chip material. Also, you want to make sure if you have any temporary staging areas where you put a stockpile, where you fill up your tanker trucks, those type of things, you want to make sure those are returned to the pre-construction condition. Then finally, they have a lot of great information in the bonus sections. They have common problems from aggregates to asphalt splattering to streaking or drill marks to exposed aggregates, uneven aggregates, asphalt on top of aggregates. That's no good. The asphalt's supposed to be on bottom of the aggregates, and then dislodged chips and bleeding and flushing. So all of these have separate little separate little sections within the FHWA checklist, and these are common problems. So if you're a new inspector, if you're standing at the side of the road and you see some dislodged chips, you can go to this checklist and you can say, hey, these are some of the things that we may need to look at. And then finally, they also have links to web-based training, some specific sources and references, and then contact information if you want more. So I know I flew through that kind of quickly, but these are all the checklists, folks. I just went over the second one, that chip seal checklist, and I went over it quickly. But all of these are the different pavement preservation checklists. So you can see they're both for flexible pavements and also for rigid pavements. Down toward the bottom, you can see all the rigid pavement applications. And this presentation will be posted. Therefore, you'll be able to click on that URL and go to all of these checklists. Or, like I said before, you can simply search the term 2019 Pavement Preservation Checklist, and it's the first hit on the top of the screen. Click that link, and then you have URLs to go to all these different checklists. Excellent, excellent resources. Now, there are some. Oh, you're good. There are some additional resources. So there's a question about SAMI, stress absorbing membrane interfaces. The University of Arkansas has a series of webinars for pavements. They're called Pavenars. So if you just go to YouTube and search Pavenar, there's a whole slew of different resources there. If you are a college faculty member, or if you know a college faculty member, the International Slurry Surfacing Association has 2 weeks worth of content for classroom modules. So if you're teaching a class on pavement materials, pavement maintenance, definitely take a look at the resources here. And if you have a .edu email address, you can get access to all of these resources free of charge, and you get the inspector manual for free. And then finally, if you want to pay a little bit of money, the University of Arkansas does have 4 asphalt emulsion certificates: the introduction to asphalt emulsions, the application, the manufacturing, and the quality. I'm very biased. I think they're very nice, but if that's something you're interested in, feel free to check it out. So we got a bunch of questions in the chat box. Dr. Zaman, did you want me to start taking those, or do you have something to say before I get started?
No, I think this is great. Thank you so much. Yeah, please go ahead and take those questions that are posted on the chat box.
Perfect. All right, the first question is, do you recommend coated chips to control dust? This is where it's a little troubling to ask an academic a practical question, because my first default answer is if you follow the design or the material standard for aggregates for chip seal, you should not have a dust problem. But I do know in reality, A lot of chip seals are placed that are probably outside of those recommended specification ranges. So I would say that if you are on a project and you are having a problem with dust to the point where you're either getting a significant amount of complaints or the material, the aggregates are not adhering to your asphalt emulsion or hot applied asphalt binder, I would recommend coated chips because that will help you overcome that excess dust problem. But in theory, you should have washed the chips so you wouldn't have excess dust, in theory. Now, there is a great comment here from Mr. Wilkinson. Thank you for providing this. They said that having the chips delivered a few months before the chip seal always helps because it allows the charge to dissipate. I mentioned when aggregates are crushed, sometimes the charge builds up. If you let it sit for a little bit, that'll dissipate. And also, natural rain will help you rinse away the dust. So that's kind of a little tip. If you have the flexibility to pre-crush your aggregate, you can reduce the reactivity and you can get rid of a little bit of dust. So thank you for that. We have a question on microsurfacing. We're talking about materials being pre-mixed on site, but then mixed in the lab for testing. So there's kind of a disconnect there. So microsurfacing and slurry seals are fascinating. You've got your aggregate, you got your water, you got your emulsion, you have additives. They're all mixed on site in a pug mill, and then they're placed out the back. So how do you simulate that in the lab? Well, I very much encourage you to go to slurry.org. That is ISSA's website, slurry.org. They have a bunch of technical guidelines and construction guidelines that address exactly these type of questions. How do you bridge what's happening in the field with what you can do in the lab? So what you're doing in the lab is representative of what happens in the field. So Mohammed, I strongly recommend you go to slurry.org. They have great resources for chip seals, for slurry seals, for microsurfacing, and for crack seal. And a lot of those type of questions are addressed in those free resources. Another question is, how do you control the aggregate embedment between 50 to 80%, and how do you measure it? Well, that's a great question. So it's relatively easy to design for. If you use that board test, and then you use that equation for the emulsion spread rate that we talked about in the design practice for chip seals, in theory, that should allow you to hit that 50 to 80% embedment, in theory. Now, how do you measure it? There are a lot of different methods you can use. One very popular method is the sand patch test. I like that because I like hockey. So you take a very specific type of sand, of a very specific quantity of sand, then you take a hockey puck and you make a real nice circle on your pavement surface. And basically you measure the diameter of the circle, how much sand went down into your aggregate for your chip seal. That gives you an indirect measurement of embedment. But the good news is there's an NCHRP project that just started that is trying to better capture aggregate embedment. There's a lot of technology out there. There's laser technology, there's picture technology. And one of the deliverables of that NCHRP project is to try and produce some better tests at measuring embedment, because we recognize the sand patch test is a test. It's an indirect test, and it may not be the best test. So this NCHRP project is going to evaluate a whole bunch of different tests to try and see if we can do a little better job with embedment. But that is a great question. And it is my impression, the final question is, do the ISSA modules apply outside of the United States? And if you have a .edu email address, you should have no problem. If you do have a problem, they have a contact email on the website. I just recommend shooting them an email and say, hey, I'm a faculty member outside the United States. Is this something I can access? Now, it appears that there may be a problem accessing the website. I am a technology Neanderthal. It worked the last time I was there. I would just recommend trying again. If it's still not working, try perhaps VPNing in off another server. I apologize, I can't help with technical problems, but I just recommend trying again.
Wonderful. Thank you very much, Andrew. And now I think, since you have answered all of the questions that are posted, on the chat box. Now, if you kindly you want to ask additional questions, you simply raise your hand, unmute yourself, and ask whatever question you want to ask. Well, in the meantime, Andrew, I think you talked about really this is very important topic, the pavement preservation, because that can be very powerful tool because we do not have enough resources to do reactive measures, right? So this is a proactive measures. Could you talk briefly about some of the important factors that you take into account in deciding, what pavement good candidate, for surface treatments?
Absolutely, 100%. Thank you for that question. So I'm going to answer that in two ways. First, we did talk about that a little bit in last week's presentation. So Dr. Zaman put the URL for the YouTube video. There's some good information there. But in my mind, when we're talking about proactive pavement maintenance on flexible pavements, when we're talking about pavement preservation of flexible pavements, there cannot be any structural problems. If you are trying to put a pavement maintenance treatment on a structurally unsound road, I'm going to go back to my Band-Aid analogy. I'm not very original, but that's like if you break your arm and you put a Band-Aid on it, you're not going to do anything. If you have a structurally deficient flexible pavement, placing a maintenance treatment on it will not do anything. So I think that's number one. And then when you start talking about identifying distresses, there are pros and cons to all those different maintenance treatments I listed. And actually, there's a lot of overlap. So I encourage you to check out roadresource.org. They go through all the different treatments and all the different mapping to the different distresses. That's a great first step. And then there's a lot of other resources out there available. But that's a great question. Stay away from structural problems and you'll be in good shape.
So one more question. Let's say
Sir.
some of the current technologies like imaging, for example, could that also be used? That question that was related to the embedment, 50% to 80% embedment. What are your thoughts on that?
I think 100%. I think that we are entering a very exciting phase of roadway infrastructure management. And that's because the technology is just phenomenal. We can drive down the road at 50 miles an hour now and measure millimeters of pavements, which means we get a very, very good idea of the quality of the pavement. And once you get the quality of the pavement, you can put it in computer algorithms. And a lot of this stuff, I think, can start to become automated. And I get frustrated personally because people think that civil engineering isn't very exciting. I think that civil engineering is a hotbed of big data, because when you think about how many hundreds of thousands of lane miles of roads we have, and if we're able to capture the condition of those roads and how they deteriorate over time, and then start mapping that to how we're able to put treatments on roads to see how long they extend it, I think there is a world out there that we have not discovered. And I think that we're starting to wrap our heads around it, but I think there's a lot more that we can do.
I agree with you 100%, Andrew, because civil engineering used to be taught as a low-tech field, but not anymore.
No.
You talk about the data that you are creating, generating. You talk about the artificial intelligence. So I just want to take maybe 30 seconds to let you all know that there is going to be a symposium on AI in motion, artificial intelligence in motion. I'm going to ask Olivia to actually send this announcement to all of the participants. So this tells you that this civil engineering is not a low-tech field anymore. All of the data that we are collecting, both the hard side of transportation and soft side of transportation, I think this is very exciting time, and also time to make original contributions. And you have touched on such an important topic. We really, really appreciate. So anyone has any last minute, last second idea, just to say anything, to our speaker who did a wonderful job. And I would like for all of us to actually give a virtual applaud. It could not be better, Andrew. Wonderful job.
Thank you, Dr. Zaman. I appreciate that.
So my last point would be, Andrew, that we we'll post this on our website. I think that would be so you can actually look at it at your leisure. And also, if you want to have another topic covered by SPTC, please let us know. And we'll try our best to actually cover that topic. Okay, so thank you all. We know that you all have a choice, and you chose to actually attend this very important meeting, important workshop. So Andrew, thanks a lot, and thank you for being such a valued member of SPTC. Andrew is the Associate Director representing University of Arkansas on SPTC, and he does a fabulous job always. Thank you
Thank you,
very
Dr.
much.
Saman. I appreciate it. Thank you, everyone. Take care.
Thank you.